Hello folks, this is Snow back here with another video, apparently in the new decade. Well, in this video I'm going to be going over how I built a robust working digital display for numbers with the input system in SimplePlanes. And as a bit of a demonstration of the system devised, here's a working digital speedometer attached to the default little bugger, measuring the speed in meters per second. As you can see from the quick demonstration, it looks quite good and also works quite well. The best thing about this digital display is that not only does it work for normal aircraft instruments like speedometers, altimeters, etc., but also for any type of number, such as custom range settings for my recently released fire assistance system. And without further ado, I'll talk about how the system actually works. In order to build a working digital display, we need to first think about how a digital display is structured. The type of digital display I chose for my system, I decided to use this type of layout with a total of 7 light up segments. In order to think about the logic of our system, we need to now think about the ways we will display our numbers. For example, to display digit 1, we will have the 2 lights on the right side light up. In another example, to display the digit 4, we'll have these lights light up as shown. In the same vein, we can lay out which lights need to light up when we want to display a certain digit, and I've done that for every possible digit from 0 to 9. I've laid out as displayed on the screen now. Now that we know how our numbers are going to be displayed on the digital display, now once again we need to think about the structure of the digital display. For the chosen type of display, I've decided to label each light of the digital display from positions 0 to 6 as shown in the image on the screen. Using these labels for positions, we can now determine from this label system and from the number display layout we made previously to determine when a light in the digital display should be active for each position in the digital display. I've done that for each position I've labeled in the digital display as shown now. In order to clarify, here's an example. For position 0 of the digital display, it needs to be active when the digit to be displayed is either 0, 2, 3, 5, 6, 7, 8, or 9 in order to result in the desired sort of display or shape that we came up with. Now that we've sort of organized the idea of what you want our lights to actually do, this is where we move on to the funky trees programming. What you want a light in the digital display to do is light up whenever a digit that requires it is the X value. Therefore, we want to have the input for the light be the value 1, which would activate the light, whenever X is a value that the light needs. To do this, we need to have a qualification operator that checks the value X if it is a required value. To do this, I chose to have 2 very close value comparison operators in a logical AND arrangement to check the value of X. What I mean by this is that if you want to check if the value of X is equal to A, you can check that if A equals X, if you do something like if you check if X is between A subtracted by 0.01 and between A added by 0.01. Although this isn't completely accurate, it's still precise enough to do everything you need. Of course, there probably exists much better ways to make this work, but this is all I could really think of. If you have any better equality qualification statements that you thought of or you could use in SimplePlanes, please leave your ideas in the comments below. We already know how to do comparison operators as laid out by a forum post made by the one and only Speffy. In his forum post, he shows us how to use comparison operators by using mathematical operations. I'll skip over the details, you should go give it a look yourself. Applying this to our idea earlier, we can realize this concept of checking if A equals A by using comparison operators by writing this. Now coming back to the light system we came up with earlier, we can now construct qualifier statements that check if A is equal to any digit from 0 to 9. Doing this, we can create statements that evaluate to a value of 1 whenever the input value X is a number we assign it. Here's a list of these statements from all numbers from 0 to 9. Moving on, if you arrange these qualifiers in a logical OR arrangement for all the required statements, we can find the input statements for each position we assigned to the digital display we formulated earlier. I did exactly that for each position, creating an input statement for each position that evaluates to 1 whenever the variable value x is one of the required values for the position. Here's a list of the input statements for each position in the digital display. Now, putting these into every light, we can now have a working digital display. I won't go over how to manipulate the number of X for use in multiple place displays, like displays that show things up to things like thousands of places, but I want to avoid that because the video will get excessively long. But if requested, I'll make a separate video on how to do that, and honestly it deserves a separate video because it also involves quite a bit of mathematical logic as well. Anyhow, I'll end the video here for now. I hope you learned a new thing today. If you have any other questions and suggestions, please leave a comment below. That's it for this video, and thanks.